In this video, we will talk about power. Let's introduce the concept of power with this quick example. The work required to be done by a force exerted by an electric motor to lift an elevator to a certain height is 90,000 joules. An electric motor M1 lifts the elevator in 10 seconds, while another one M2 lifts the elevator in 15 seconds. This means that M1 delivers an average of 9,000 joules per second, or 9,000 watts, while M2 delivers an average of 6,000 joules per second, or 6,000 watts. The forces exerted by both motors do the same work, but the one exerted by M1 delivers more power than that exerted by M2. Power is the rate at which energy is transferred from one system to another or converted from one type to another, or the rate at which work is done by a force. It is the amount of energy transferred or converted, or the amount of work done by a force per unit time. Average power P bar is equal to the amount of work done delta W, or just W, over the corresponding duration delta T. Instantaneous power is equal to average power when the duration is very small. It is given by the formula P equals the limiting value of P bar as the duration approaches zero. Thus, it is equal to the ratio delta W over delta T as delta T approaches zero. This gives dW by dt, which means the time derivative of work. To find the instantaneous power delivered by a force F, we replace its infinitesimal work dW by the dot product of F and the infinitesimal displacement dr of its point of application. But dr by dt is equal to the instantaneous velocity v of this point. This finally gives the instantaneous power delivered by F equals the dot product of vectors F and V. In the International System of Units, W is expressed in joules, delta T in seconds, F in newtons, V in meters per second, and P bar and P in watts. Example, a skier of mass m equals 80 kilograms slides down a ski slope making an angle of 30 degrees with the horizontal. Calculate the instantaneous power delivered by his weight when his speed is v equals 12 meters per second. Take g equals 9.8 meters per second squared. Note that instantaneous is written between parentheses because whenever we say power without specifying, we are talking about instantaneous power. To answer this question, we write the formula giving the instantaneous power delivered by the weight, where alpha is the angle between the weight mg and the velocity v of the point of application of mg. On the figure, we draw a right triangle having a horizontal side, a vertical side parallel to vector mg, and the hypotenuse parallel to vector v, thus parallel to the slope and making an angle of 30 degrees with the horizontal. The angle between the vertical side of the triangle and its hypotenuse is equal to alpha since their sides are parallel. And since the sum of the angles of a triangle equals 180 degrees, alpha equals 180 minus 90 minus 30 equals 60 degrees. We plug in the values in the formula and we get 4.7 times 10 to the 3 watts. And this is all for this video. Thank you for watching.